Hey guys, this is Algebra 2, homework number 27. Part A is 16 to 40 even. Part B is 42 to 62 even. I'm going to pick a few of these problems to go through so you guys can check these. Hopefully you get it as you're working on it. So what we're dealing with quadratic equations that are set equal to 0. And we're looking at the quadratic formula and later on the discriminant. So these first couple problems are just, hey, show me A, B, and C. Well, in order to show you A, B, and C, we need to get to the fact that you have ax squared plus bx plus c equals 0. So notice I have everything on one side and a 0 on the other side. I'm going to leave, I have two of them here, so I'm going to bring the third term over. Subtract 2, those cancel out, that gives me 0. Now I'm going to write them in descending order, 2x squared minus x minus 2, and now when they say, hey, tell me what a, b, and c are, a is the coefficient of x squared, that's 2. B is the coefficient of x, understood as 1, that's going to be negative 1. Oops, let me undo that if I can. All right, I think I've fixed that. So, let me get my pen back. All right, so we have b equals negative 1, and c is the constant, negative 2. Okay, so that's what we had to do there. Just tell me what A, B, and C were. Okay, why do we do that? Well, we're going to start using the quadratic formula. What does the quadratic formula tell us? Anytime I have a quadratic equation in standard form, ax squared plus bx plus c equals 0, then I can solve for that by using the quadratic formula. That tells me x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now we're going to use that to do these problems here. So first part, tell me what a, b, and c are. I don't need to write these out every single time. I'm doing it here just to hope these make sense. So a equals negative 3, b it's understood as 1, c is negative 2. So x equals negative b, which means the opposite of b, plus or minus the square root of b squared, so that's going to be 1 minus 4 times a, which is negative 3, times c, which is negative 2, all over 2a. That's 2 times, that's a negative 3 right there. What is this equal to? Negative 4 times negative 3 is positive 12, times negative 2 is going to be negative 24, so I have 1 minus 24, and that is going to be negative 23, plus or minus the square root of negative 23, all over 6. And now I'm going to end up just simplifying this. And which number are we doing here? We're on 34. So I have to take care of the fact that I have a negative under the radical. And let me just put this in green. So our final answer, because there's no perfect squares that go into 23, so I have negative 1 plus or minus I times the square root of 23 all over 6. And this is our answer. Okay, and that's an I. And again, just a reminder, I equals square root of negative 1. Okay, so we are using the quadratic formula. I don't expect you to be able to generate this from scratch like we did in class, but I do expect you to memorize that. Okay, and that's something we got to keep working on. Okay, let's do number 36. Same thing, it's already in order. I'm not going to write down the A, B, and C. A is negative 1, B is 3, and C is negative 9. So it's negative B plus or minus the square root of B squared, which is going to be 9, minus 4 times A times C. So A is negative 1, C is negative 9, all over 2A. So it's 2 times negative 1. Negative 4 times negative 1 is positive 4, times negative 9 is negative 36. So I have 9 minus 36, that's going to be negative 27, all over negative 2. I do know there's a perfect square that goes into negative 27, and that's going to be 9. So I'm going to break this down to the factors of 9, square root of negative 1, and square root of 3. So this is going to be negative 3 plus or minus 3i square root of 3 all over 2. And since there's nothing that I can take out of both the numerator and denominator, I'm going to just leave it like this. So yes, there's a negative 3 and a 3i up top, but I can't factor it out because there's nothing I can cancel it with in the bottom. Okay, keep going with these evens. Now they give me two problems here, 40 and 42, where it's not equal to 0. So I have to make it equal to 0. So I'm going to rewrite it in standard form, which is in descending order. Negative x squared plus 5x, bring the negative 7 over, so I end up adding 7 to both sides. So plus 7 equals 0, and now I just use the quadratic formula. X equals negative b plus or minus square root of b squared. Let me try that again. So negative b plus or minus the square root of b squared, so that's going to be 25 minus 4 times a is going to be negative 1, times 7, all over 2a, 2 times negative 1. Negative 4 times negative 1 is positive 4, times 7 is 28, 25 plus 28 is 53. That'll be a positive 53, all over negative 2, and there are no perfect squares that go into 53. And which number is this? This is number 40. And this ends up being our final answer. Negative 5 plus or minus the square root of 53 over negative 2. Now, we could also see this as negative 5 and negative 2, and some people will write it like this. I would accept this right here. Plus or minus the square root of 53 over negative 2. So the negative 5 over negative 2 can become positive 5 halves. And then this is plus or minus, so it doesn't matter when it becomes negative. It's still going to be plus or minus. So you may see it in the back of the book as positive on both sides, the 5 and the 2, which you factor out a negative 1. The fact that this is plus or minus doesn't matter, but I would accept this right here. Okay, whatever's easier for you guys. This one, same thing, 42, I got to write in standard form, descending order. 2x squared, subtract 15x from each side, subtract 9 from each side, equals 0. Now let's put this into quadratic formula. X equals negative b, so that's going to be positive 15 plus or minus the square root of b squared. Negative times negative is going to be a positive. 15 times 15 is going to be 225. 4 times a times c, all over 2a. Okay? Negative 4 times 2 is negative 8, plus 9 is, times negative 9. 8 times negative 9 is 72. So I'm going to get 72. Sorry about that. So it's 227 plus 72 is going to be 297. We get 15 plus or minus the square root of 297 all over 4. Let me just block off where this last problem was. Okay, let's come down here. Equals, and you might not see it, but this is the same as square root of 9 times the square root of 33. So 9 is the biggest perfect square that goes into it. 15 plus or minus 3 square roots of 3 all over 4. Those are my two values of x that make this true. Okay. Number 48, same exact problem. So let's first rewrite it. 2x squared minus 20x plus 75 equals 0. X equals negative b, so that's 20. Let's try that again. 20 plus or minus square root of b squared is going to be positive 400. Please make sure that's always positive. 4 times 2 times 75 all over 2a. 4 times 2 is 8. 8 times 75 is what? 600. 400 minus 600 is going to be negative 200. So 20 plus or minus the square root of negative 200. Hopefully someone's checking my math out there. X equals, and what I end up getting is 20 plus or minus. Now this can be broken down into square root of 100 We still have the -1 there, and the 2. So, and where are we? We're on 48, so I'm going to get 10i square root of 2 over 4. And we talked today about how the fact I have a 20, a 10, and a 4. 2 goes into all those. So I'm going to get 10 plus or minus 5i square root of 2 all over 2. And that's going to be our answer. Okay? 50, they have a long problem there. It says find the error. And so it's 2x squared plus 4x minus 7 equals 0. A is 2, B is 4. We know from right here, the beginning of our quadratic formula, it's x equals -b. Well, the opposite of b is -4, but they don't write it as -4. So that's our mistake right there. So they go through and do all that work, and they were one sign off. So that's what they were trying to get you to do on number 50. Okay, discriminant, b squared minus 4ac. And again, if b squared minus 4ac is positive, then we get 2 real solutions. This is what we're trying to figure out here. If b squared minus 4ac is equal to 0, we get 1 real solution. And last but not least, b squared minus 4ac is negative. We get 2 imaginary solutions. Okay, so let's go through. I don't have to go through and do everything. The whole quadratic, they just want to know how many solutions and what type are they. So I know b is -11, so it's going to be b squared is 121 minus 4 times a times c. 4 times 5 is 20 times 9 is 180, so 121 minus 180 is going to be negative. So once I know it's negative, I'm going to get 2 imaginary solutions. Okay, and I don't think they were looking for what the find the discriminant. I'm sorry, they are looking for the actual value. So 121 minus 180 is -59. I'm sorry, the directions did say find the discriminant. Okay, now on this one, I first have to write it in standard form and set it equal to 0. So if you counted c as positive 15, you're going to get that one wrong. So it's b squared. So 121 minus 4 times a times c. And what is this going to be equal to? That's 121. 8 times 15 is 120, but it's going to be a positive because the negative times a negative. So 121 plus 120. So this equals 241. And therefore it's positive, so there's 2 real solutions. So the discriminant is 241. And there are 2 real solutions. Okay, so we had one where it was negative, and we had 2 imaginary solutions. One where it's positive, we get 2 real solutions. Now let's check this last one. Again, write it in standard form. 4x squared plus 32x plus 64 equals 0. Oop, I made a mistake. This is supposed to be negative 32x. So when I bring that over, totally forgot. Okay, let's not make that mistake. It's the whole thing I just said last problem. So 32 squared, I cannot do that in my head, minus 4 times a times c equals 0. And let's get a calculator out. With the calculator, we get 32 times 32 is 1024. Now let's do 4 times 4 times 64. Hey, we get 1024. So I just found out that my discriminant equals 0. And hold on, I wrote equal to 0 before I did the problem. That's not supposed to be like that. So this is my discriminant. We find out it's 0. So whenever our discriminant is 0, we get 1 real solution. Okay, so I did one example of each type. Okay, that's 1 real solution. Okay, so hopefully that helps. I don't believe I did any more problems here. So this whole section is dealing with homework 27, quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Good luck.